also used implicitly the notion of the matrix transpose. If the matrix A is something like A, B, C, D, E, F, then the transpose of the matrix is
A, C.
A, B, C.
You can write it down. Now a little bit more, not even complicated, but mathematically demanding, time demanding exercise is 3x3 matrix. And now again, if we have matrix A as 1, 2, 3, 0, 1, minus 1, 1, 2, 1. The probable task is to find the matrix in the row. I think we won't have much time to go through the entire process of Jordan-Gauss elimination, so I will just think I can make the first step and leave everything else as the home assignment. I'm a bit sorry that I gave you the home assignment so early. But well, this is the life at KSE. It's always home assignments. 2 years. Again, we write down our initial matrix and the augmented matrix. And then we start our eliminations. Again, first we leave the first row intact, which means 1, 2, 3, 0, 1, 0. Then we have leaving 0 in the second row. And in this particular case, we leave the second row the same as well. 0, 1, minus 1, 0, 1, 0. And then we have to obtain the leading 0 in the last row, and the simplest way is to subtract the last row from the first. 0, 0, 2, 1, 0, minus 1. So we have got a very nice triangular matrix here, and then we again keep the second row the same, transform zeros over here. Then we keep the first, the second row, the middle row the same, getting 0 over here.
Excuse me, the missing minus 2.
1 minus 3 is minus 2.
Yes.
Thanks.
No,
Here.
0, then minus 2.
On the 0, 0. On the right hand.
0, 0, minus 2.
Why minus 2? 1 minus 1, 0 minus 2 minus 2, 3 minus 1. 1 minus 0, 0 minus 0, this is minus 1. I think it's 0 here, it's 2 over here.
2 minus 2. Where?
Or here? No.
Yes.
Why? 1 minus 1, 2 minus 2, 3 minus 1. Because if you subtract the first from the 0, they're going to be 0 minus over here and plus over here. But we subtract the last from the first, so it's plus 2. So the ultimately it's going to be something like 1, 0, 0, 0, 1, 0, 0, 0, 1. So let's change to negative 2, 2, and 2. And here we are going to have 3, 4, 5, 1, 2, minus 1, 1, 0, minus 1. So this is negative 2, 2, and 2 over here, 3, 4, 5, 1, 2, minus 1, 1, 0, minus 1. If you divide all the rows by negative 2, 2, and 2, you will get the inverse matrix over here, and all the steps in between is your home assignment that you kind of get a grip of how to do this one. And I actually recommend you to run several more matrices with this kind of assignment so that you understand better how to do this Jordan-Gauss elimination work. We'll just write down at least one more matrix, which is kind of easy to work with. Now we get back to the skills that we use here and that we have to know as well. This is number 6. The number 5 was after the first example. This is number 6, which is Jordan-Gauss elimination. And number 7 you have to know how to find by Jordan-Gauss elimination inverse of any n by n matrix. The next one. Here's some problem. You would probably need something like graph paper, but I think you can graph it only up to the axis by 6 by 6. So build vectors. Vector A, which is 3 and 1, and vector B, which is 2 and 4. And after you have built those two vectors, find vectors A plus B and A minus B. And why don't you try this in your notes right now? So if we build those vectors, the first is going to be this one over here. This is our vector A. The second is vector B, which is 2 and 4, somewhere around here. I think it should be very simple how to build vector A plus B. What about vector A minus B? So it goes like this one. Where do I put the arrow? Over here, over here?
To A.
Down, okay. And the next assignment, find the area of this parallelogram. I will call it, this is going to be O, this is A, this is B, this is C. So find the area of OABC. The first one to give the answer will have a prize in the form of the public